Alrighty, so this is 7.5. The objective of 7.5 pretty much is to solve exponential equations and logarithmic equations. And I'll try to show you as many different ways that we can. Please don't let that confuse you. If you like one, pick it, get good at it, and then try the other one later. But eventually you will need to know both because obviously when we start doing our finals, especially those written finals, they're going to ask you to do it both ways. So, objective today, solve equations that are exponential equations and logarithmic equations, okay? Just a quick reminder, headphones, laptops, cell phones, I'll put away. Let's get to this. Can I change the slide? What do you got?
What do I do since I didn't do something else?
We'll talk after, okay? All right. Can we get started? Nope. I like that. Your shirt. It's amazing. I need to put some more color on mine too, but I've been too lazy.
Give it a black background.
What?
Give it a black background.
Nah, it's too busy. Can you imagine a black wall back there? It was be all doom and gloom and sad.
No, you just dress it up in a black color. That actually be pretty cool.
You're wearing more black than I am.
Your hair is black.
No, the gel I put in my hair makes it look black. All right, moving on. Here we go. We're going to start with solving an equation that we can put into a common base. So common base exponential equation. So let's take a look at what that looks like. You guys see that okay? Last hour said no. So I'm going to go ahead and rewrite that. This is 16 to the 3x is equal to 8. Now let's not lose sight of what we're trying to solve here for. When we're trying to solve an equation, what are we looking for? The x, the unknown. In this case, x is an exponent, isn't it? It's 16 to the 3x, and that equals 8. Now, we're going to play with math, and we need to know some of the rules. And these rules you should have already picked up first year algebra last semester when we were talking about exponents and stuff. So what I'm going to do is I'm going to play the math game here to try to make it work in my favor. Does that make sense? So this is where you start playing. We were learning the rules before. It's time to play. So take a look at those two bases, 16 and 8. Is there a way to get both of those to have a base of 2? Well, actually, I should have said a common base, and you were already thinking 2, right? Like I can make those be a 2. Let's start with the 8. How can I convert 8 to a base of 2? Not divide. Remember, we're talking exponents. I know that some people use that as a skill to get you the number. So it would be 2 to the 3rd. So 2 to the 3rd would give me that. And let me repeat that. That's not wrong what you guys said when you said divide. I know people use that as a tool to try to get you that number. But can we all agree that that is 2 to the 3rd power? Yeah. Someone not agree with that? I challenge you. All right. Can we do the same thing with the 16? What would that 16 look like? Well, remember, we want a common base, right? So we want it to also have a base of 2. 2 to the 4th, doesn't it? So that 16 becomes 2 to the 4th. 2 to the 4th definitely is 16. Now that is to the 3x. Is everyone okay with what I've written here? I've converted the 8 to be 2 to the 3rd. And I've converted the 16 to be 2 to the 4th. I can do that. Math. Now, I'm going to clean this up a little bit because it still looks kind of weird, right? Now, don't like that. 2 to the 4th, 2 to the 3x. I just have to use my power of a power rule. You guys remember power of power rule? That's saying that if I got a power to a power, I can just multiply those two. So what's 4 times 3x? That is 12x. And that equals 2 to the 3rd. Now take a look at this. This is really, really cool. I have an equation. What does it mean to have an equation? What can you tell me about both sides? They're the same, right? So we can make some conclusions about this. If both sides truly are the same, then that means that if this is something weird, and that's a 3, what can we say about 12x and 3? They are the exponent, but if this is an equation, then what can we say about the 12x and the 3? They're equivalent. They're also the same, right? Look, the bases are the same, so both sides are really the same. That means that 12x is equal to 3. That's kind of weird, but that's okay. Because all we're trying to do is figure out what x is supposed to be. But I can make that statement. I can definitely say 12x is equal to 3. Do you see that? And then all I have to do at this point is solve this linear equation. I'm going to divide both sides by 12. That means that x is equal to 1/4. And I've just solved that exponential equation. I'll show you the whole screen now. You guys can copy that over. Not so bad, huh? Isn't that cool? Go math!
You're weird.
Thank you.
So basically all you're doing with this is working with the exponents.
We're solving equations now. That's what we're doing. In this case, they're exponential equations, and of course, they're going to be logarithmic equations because they go hand in hand, right? You guys good? All right. You try. You try.
This better not be a trick question, right?
Tis not. Tis not. Tis not. It is not. This coffee did not last today. Give you guys a few minutes. I'm gonna have Dojo call somebody.
With this, does the exponent have to be the same when you're converting it?
No, what we want is to have the same base, because then we can make conclusions about the exponents.
Okay, so we could pretty much put the exponent in exponent.
You guys another minute? The back probably went up. I need to order a new one. Nice. I like love chicken.
I do like.
Okay, that sounds like a haircut machine. Those hair trimmers. Try that one. We're done? No? Alright. Definitely have to order something. Alright, question goes to Kaylee.
Okay.
Tell me what you did. Come on down, do it. Go, 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 fast, fast, fast. I think I'm gonna start calling multiple people. I'm going to board.
Wow. I'm too short for this. Okay.
Can I get a second? Yeah. And a third. All right, good job. Now she did skip a few steps. That's okay. That means you know what you're doing. So she took the 27, turned it into 3 to the third, because that is 27. The 81 is 3 to the fourth. Now, how did this 3 become a 9? X? Well, she multiplied it by the 3x that was already there. So that became 9x. And then she just solved that equation. Good job. Yeah? Zach? Fantastic. All right. Can I switch the slide or somebody still right there? Okay. I can wait. ¿Preguntas, Sofía? Question? Where? Here, let me. Right? That's what it is, yeah. So then once you get that 9x equals 4. Yeah, she skipped that step, which is okay. Just fine. Now, these were pretty simple, right? Was everybody able to see that the common base was 3? Let me throw some rocks. Let me throw some salt your direction. Solve exponential equations that you can't put into the same base. Most of you will take a look at this and be like, what can I do? You're going to try to do it. You're going to try to do that. What is the common base here that you would try to do? My first instinct would be 15. My first instinct would be 15, right? Try to get a base of 15. Everyone agree with that? No? What would you try?
I'd do 5.
You do 5? That's not a bad question. So let's see here. So if I did 5.
Oh, yeah, okay, that makes sense.
Okay.
Never mind.
I can do that too. Anything else we can do? It would have to be 15, right?
Yeah.
So, is there a way to get 285 to have a base of 15? Anybody ever have any ideas how we could do that?
What?
How we can get 285 to have a base of 15, if it's possible? What would it have to be? You don't know how to do this? You should. I've already shown you. Let me here. Think about this. I want to know if I can take 15 to some exponent and get 285. Not E. Now here's the question, right? Can I take 15 to some exponent and get 285? That is the question, correct? Now do you remember I said this is not the way we ask this question, is it? How do we ask this question? This is a log question. It's a logarithm. A logarithm is asking for an exponent. So the question would be log base 15, 285. And what I'm going to do is I'm going to go over to my handy dandy calculator. I'm going to quit this. And I'm going to ask it that question. Let me clear this. I'm going to say, hey, math, log base.
It's 2.087.
So if I took 15, the base of 15, and I want an answer of 285, 285, right?
Yeah.
What exponent would that be? And the answer is 2.085. So what's that tell me? I can't do that. There's no way to do it because that is not a whole number. If that was a whole number, then it would be 15 to that answer, or whatever that log would give me the 285, but it's not doable here. So the question is, what do I do? What do I do? So let me clear this ink. What do I do? Well, logs is still the answer. Logarithms are still the answer. Logarithms are still the answer. Back when we first started doing equations in algebra, there was a golden rule, wasn't there? You remember what that golden rule is, Dylan? I was going to try to do my holy voice, I can't. My commandment. Do you guys remember the first commandment? Anybody get told the first commandment? Do to one side what thou dost to the other, right? It's like 10 commandments of math. It's weird. But anyways, whatever you do to one side, you got to do to the other side, right? Here's what I'm going to do. I'm going to take the log of both sides. I should not do it there. Let me redo it instead. I'm going to take the log of both sides. So this is log of 15 to the 3x. That should equal the log of 285. Now, Mr. Munoz, why would you make this problem harder by introducing logs? I can see it on some of your faces. Why? Why would you do that? Well, this is why. We're good? What happened?
I didn't know how you do it. Is it?
It's the same thing up top, except I took the log of each side. So now it's log of 15 to the 3x is equal to log of 285. And of course, those are base 10s, right? Now, the reason why I did that, remember with the logarithms, there was that exponent rule? You guys remember the exponent rule? If I have a logarithm and the answer or solution has an exponent, what can I do with that exponent?
Move it.
Yeah, I can move it to the front. So now that becomes 3x, 3 times x times the log of 15 is equal to the log of 285. And what am I trying to do? What is the objective of trying to solve an equation? To find the x, or the unknown. In this case, it's x. What's happening to x?
Being multiplied by the log.
So how do I undo multiplication?
Division.
Division. So I'm going to divide by the log of 15. Is that the only thing that's being multiplied by?
No,
And the 3. So I'm going to divide by 3 times the log of 15 to both sides. So 3 log of 15. 3 over 3 is 1. Log 15 over log 15 is 1. And at this point, I get x equals. What am I going to do at this point?
So would it be like 3 log 19?
No, please do not do that. Please do not go 285 divided by 15 and try to simplify that. It doesn't work the same way. But what I can do is I can throw all that in my calculator. Okay? So I'm going to go and listen to my calculator, go over to calculator. Let's clear this. Now, I do want to make sure I keep my numerator together and my denominator together. So what I'm going to do is I'm going to do something like this real quick. I just want to show you the format. I'm going to take the numerator in parentheses and divide it by the denominator in parentheses, okay? That's the idea, so that when you see it, you know what I'm doing. So let me start this again. Parentheses, my numerator was the log of 285, correct? I'm going to close this parenthesis to close my log, and I need to make the other matching one to close that one there. You want to see that? So that's my whole numerator together, and I'm going to divide that by my denominator. So I want my denominator to be all together, so that should be 3 times the log of 15. I'm going to close this parenthesis for the log, and then this one for my denominator. So it looks like this. And now I just press enter, and that's what x is equal to, which is approximately 0.7. Which is approximately 0.7.
That's your answer?
That's what x is, yes, that's the answer, that's what we're looking for. Questions? Huh? Yeah, you do one next. Ah, that's a good idea. You gotta be careful. All right, can I change the slide? No, a little bit more. This coffee did not last a day. It was too cold. I kept sipping it to try to warm me up. Good stuff though. We got some of that hazelnut. You ever drink coffee? No? Hazelnut? Oh. Caramel? Caramel? Praline?
Crazy.
Yeah, I like a dark roast myself, but we were at Sam's Club yesterday and like, oh look, there's some hazelnut. So like stuff was all discounted, so I'm like if there's anything you ever wanted to try it now. So we got some of that and stuff's good. It's like a hazelnut vanilla. Yay, hazelnut vanilla! Alright, here we go. You try one.
Wait. There. I just want to make sure I have it.
Go! You can do it!
Who knows?
Go back?
I didn't write it because I was watching him do it.
Oh, that's very nice. Thank you. Here you go. 5 to the 2x is equal to 130. I'll give you guys a couple minutes here. We'll go 2. I'll come back to you. Despierta, bella durmiente. ¿Tuvieron que haber ahora? Tempranito. ¿A qué hora es? Oh man, that's bad.
Try catching the bus at 6.
My college algebra class, when I first started college, my college algebra class started at 6:45. Started at 6:45. También se iba cansado. Sleepy. Sometimes I don't even know how I got there. Did that ever happen to you guys? No? Oh man. So tired, like, wait a minute, where am I at? That's good.
Wait, what if you can divide it into
What if you can't?
You can't.
You could turn that into a base 5?
Oh. Okay.
I can check. I don't know if you can, but let me check it. I would go second entry.
Closest thing is 125.
Yeah, it would be 125, huh? What's the answer? 130? Yeah. Just a little bit more than 3. Yeah, because 3 is 125.
Is that the answer?
No.
Oh.
No, we were checking if we could turn this into a base of 5, which we cannot. We cannot. Ooh, hello? Yes. Faith. Thanks for participating. What'd you come up with so far? Can you turn that into a base 5? No, so you gotta go with the algebra mode. What do you got?
The answer?
What'd you come up with? Yeah.
1.2.
Oh, well, what'd you do here first?
Oh, I divided them.
You divided them?
I mean, I put it in the log.
You took the log of each?
Yeah.
So log 5 to the 2x and log of 130?
Yeah.
Then
Then I put the 2x.
you took the 2x,
Put it in front.
put it up front. So that gave you 2x times the log 5 of 5 equals log of 130.
Yeah. But then I
Log base 10 of 130. And then
I divided.
you divided by 2 times log base 10 of 5. So x is equal to 1.5 up 1, 2. Can I get a second? The third, fourth. Woo, nice. He's nice. Amen. Zach, we're good? David?
Okay.
Okay, so those Those methods were algebraic methods. Okay, so we did them with algebra. Personally, I like the algebra a little bit better, but there's also a way to do that with geometry. No, wait a minute. It's just more tools for your toolbox. Look, here's this problem.
I'm rapping now.
You rather would. Actually, you know what? I don't know. It's up to you what you want to do. Here we have 4 to the 3x is equal to 6,000. Now, obviously, you guys can see that. Maybe we can throw that into an equation with log both sides and then do all that good stuff. Maybe, I don't know, we can get a base 4, maybe even a base 2. But there's other ways to do it as well, which is with the geometry, and we can graph these things. So let's stop and examine this for a minute. This is saying that when I took this function, I got that, right? So technically, that means that the parent function here is y equals 4 to the 3x. Does everyone understand that? It's written backwards, but if I put x in, it spits out y. It spits out y, right? That means that this was the value of y. Okay, does that make sense to everybody? So I've got my function. Guess what I can do with that function? Obviously, graph it. Okay? Now, I can do it with the 84. Some people don't have 84s, and yes, they are pricey, but they're worth an investment. I'm going to show you with Desmos right now, and then if you guys want to see with the 84s, I can show you that. But here's what I'm going to do with Desmos. Kick my way over here. I'm going to delete that real quick. What was our parent function? 4 to the 3x? So 4 to the 3x. That's not a 3 at all. 3x. So there's the function. Let me reset this real quick. So it looks like this. You see, choo, and that's exactly what a power function is supposed to look like, right? Exponential growth. Now, what was the value of y here? 6,000, right? So what I'm going to do, something just simple, I'm going to mark 6,000. So I want to know when y is equal to 6,000, and I can do that.
That's 600.
600. So there's 6,000. Press enter, and that should hopefully put a line up there. Ooh, I should zoom out. Ooh, a little more.
Yeah, a lot more.
Ooh wee! There we go, little thousands there. So there's our line for 3,000. So what I need to do, what's that? So all I did at this point was just to try to get to 6,000, and I'm going to go back and zoom in now. So as you can see, that line right there is what represents y being 6,000, and there's my function here. So what I'm going to do is I'm going to look for the intersection, and that means that my solution, or the value of x, is 2.092. Okay? And of course, you could do that also algebraically. You'd be just fine. Did you do it with the calculator?
Yeah.
Fantastic. The way to do it with the calculator, there's a couple ways. Can we do that real quick? You guys good? You guys ever see that? If not, you can always reference a recording. I'm going to go here. And what I want to do is I want to go to this y equals button. That's going to let me punch in 4 to the 3x. And I'm going to press on graph. Oh, there it is. Yay. Couple different things I can do here. I can use the trace feature. You guys know what the trace feature is? There's a button that says trace right here. Pop. It's going to put a little point on here. You see that? Yeah, and it'll tell you where it is. It's at coordinates that's 0, 1. I want to move it so that y becomes how much? 6,000. So I'm going to be there for a while, wouldn't I? Oops, that was too fast. Yeah, it's going to jump after a while because of exponential growth. So take a look here. I went from 3,000 to 6,000 some change. That's not very the best, is it? So that's not going to help me out. What I can also do is go over to my table. See that there? So I can go over to the table, and I can see that this goes from 2,000 to 1.68. So table probably won't be the best way that I could do it. But there's somewhere you can. But that's exactly what I'd be looking for. I would just look for where this is 6,000. It looks like it's between 2 and 3, right? Let me go over to table set. Do you guys see that table set here? It's right above window. and I can change these. So I can change it to start maybe, let's see here, what do we want to do? Change the table by how much? Maybe 0.5? Maybe a 0.5? And then we'll go back to the table. Let me push enter first, make sure it takes a change. So second table, and now I should see that the table goes by 0.5, see that? So now if I get a little closer here, I can see that difference there. That's not good enough for me. I can go back into the table set, and I can change it to a 0.25. So I'm going to go back here, go 0.25, press enter so it takes effect, jump back to the table again. And let's see here, I'm going to have to scroll down a little bit. And also I can change the starting point too. That way I don't have to scroll down so much, because I know it's going to be above 2. See that? So I can go table set. I can say don't start at 0.25 anymore. Start at, I know it's bigger than 2, right? So I can say start at 2, and maybe I want you to go by 0.1. And then I can see a difference there. And I can go over to the table. And I'm going to show you guys another something right now with the Desmos as well. So here we go. See how it just keeps getting closer and closer? So you can kind of be there for a while. Let me go back to Desmos, because this one was kind of cool this way. I don't know if I was able to get the exact one, but let's do this real quick. I'm going to get rid of this, and I'm going to actually use the table as well in Desmos. So table, and I've got my x value, and I want this side, no, not you, I want this variable to become my function. So this was 4 to the 3. Now, that x has to match the x from the other part. So that is x sub 1, correct? You guys see that? Now, here, I need to put in some numbers. So let's start with 1. Gave me 64. Obviously, that's not close, is it? So maybe I go with 2. And then if I check 3, I went too far, didn't I? So now I know that my answer is between 2 and 3. So what I'm going to do is over here, I'm going to go 3.5 maybe. Oh, way too, oh, that's not what I wanted. 2.5. 2.5, still too big, so I need to make that 5 smaller, maybe a 4. 3, 2, 1. That's definitely under, what do I want? I wanted 800?
6,000.
6,000, okay. So that's kind of close, isn't it? So do I want the 1 there? I want it smaller than the 1, don't I? So I'm going to put in the 0, and then I'm going to put in a 1. Is that high enough? I'm going to change it to a 2. That came up, didn't it? Change that to a 3. Change it to a 4. Change it to a 5, a 6, a 7, 8, 9. Ooh, 9's pretty close, isn't it? So after that, I'm going to just add another 1. That didn't make it, so I'm going to go 2. And what I'm looking for is when I jump over the 6,000. And I don't want to jump it, so that means I need a 1 here. And then I'm going to add another 1 here. Maybe a 2, maybe a 3, maybe a 4, 5, 6, 7, 8. 8 makes a jump, so that becomes 7, which is right under there. And then I keep playing the decimal game. Does that make sense? Little pieces, little pieces, little pieces. So then I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoa, wait a minute. I think that's as close as we're going to get. So that's a pretty decent answer, yeah? And of course, they always want you to round it anyway. So there's another way that you can do it. And again, if you need to look back at that, you can always reference the recording, and you should be good there. So a bunch of different ways to do that. Any way you want to do it, be fine. Personally, I'm the algebra guy, because I know that I control the entire process, and then I just have my calculator figure out some numbers. But if you want to graph it too, that's good. You will eventually need to know both. It's up to you. It's up to you. Okay? Here, you try. Give you guys a couple minutes. Do-do-do-do-do-do-do. All right, let's call somebody here. Brian O'Connor. What route did you go? Which way did you go? Graph or? Algebraic? Okay. Did anybody do the graphing method? Well, you have your calculators, right? Oh, we said that was a little tougher, wasn't it? Decimals. Definitely would be harder. Of course, if you are going to do the algebraic method, then if you did the algebraic method, then I'm sure you went with log to both sides. So log 7 of 4x is equal to the log of 800. Kick that 4x to the front. Yeah? Right. And then we've got log of 7 is equal to the log of 800. Dividing both sides by 4 times the log of 7. 4 times the log of 7. That becomes 1, and that's what x is equal to. Just a matter of punching into your graphing calculator. What did you get? 0.85. Can I get a second and a third? Good. All right, let's move on. Thank you. 0.85. 0.85?
I got 1.16.
Well, let's take a look here then. We've got a challenger. So let's clear this. So we went parenthesis. What was it? Log what?
Log.
Oops.
800.
Log. The log of 800. Close. Divided by 4 log of 7. Oh, I forgot a parenthesis here. Thank you. Watch how I do this, though. Over the 4. Next to the delete button, the second option is an insert button. So then I can just insert a parenthesis there. Pretty cool. Press enter. 0.85. What did you do in Desmos?
So, wait, okay, try this.
I can hold on for a second. And we hold it. S'il vous plaît.
Okay, so I put 4 log 7 first. And then times by log.
Oh yeah, that's something else
That's
altogether.
what I got.
All right, cool. So,
Okay. So I had a question.
yay.
So, say we have a problem and it's with the same base. We have to use like same bases. Could you use the log with the same?
Yeah, if you didn't want to do the same base type thing, logs still work.
Okay. I'll just.
Different strokes, different methods, whatever you want to do. Okay. Now logarithmic equations. So this is the other way. So now we have, what is the solution of log of 4x minus 3 is equal to 2? Okay. This says what is the solution to log of 4x minus 3 equal to 2? Now, when I first saw it, I just went, dropped the pencil like you just killed it, right? I was getting it and I don't get it now. Please don't do that. I'm all nosy too. Please don't do that. Don't give up right now. Everything before was okay, right? And you guys were good with it? Well, this is the same question, but backwards, isn't it? Before, we introduced log, didn't we? And we added log to both sides, and then we did all that whole business. Well, this is in log form. If we don't want log there, let's get rid of it. Okay? This is how we do it. We're going to take both of those sides, and we're going to make them exponents with a base of how much? Anybody take a wild guess? What base is this log in?
10.
So guess what I'm going to make my other base? 10. Why would I do that? Why would I do base 10 log 4x minus 3 is equal to 10 to the second? Why would I choose a base 10? Nice and loud? They're inverses. Guess what happens with 10 and log base 10? Gone. And yes, that's hard to believe, but this exponent now becomes the base value. Minus 3. It's a minus 3, sorry. So on this left side, base 10 and log base 10 is simply 1. And 1 times that mess there becomes that mess there, 4x minus 3. What is on the right side? Which is 100. We're going to add 3 to both sides now. And we've got 4x is 103. Final step? Which property? Nice job. Division property of equality lets me divide both sides by 4. If you don't know what those properties are from before, please make sure that you know them now, because we are going to pick up our writing again. So we've got, what is this? 25.75? Because it'll be 3/4 at the end. There we go.
Oh, 75.
Yeah, if you take a quarter of 100, and then you'll end up with the 3/4. See that? Well,
Kind of cool though. I never saw that.
oh, well, yeah. Yay! Math.
11. Or 7. No, because I said 107.
Yeah.
Moving on up. East side. Oh, you want to see the whole thing? Yeah. Boom. What's up?
Can I shoot out a quick text real quick?
15. It was 16, but I took one off. Like there's no need to do all that. What's up?
For the homework, if it's possible, you can unlock the entire week for me so I can just try to get it tonight. Because I won't have time.
I can't unlock them. They have to be they're pre-made. They're not pre-made. I do them after the lesson every day. But we've only got one section left, so.
Like,
Really?
7.6 is the last one. You could start working on the review. That's open also.
It's open.
When's the test?
On the 30th.
30.
It was the 29th, but we didn't want to test you on a Monday.
Bless your soul.
So we'll start chapter 8 probably. And just a heads up, I'm going to be gone Thursday as well.
Why?
I'm going to go work with the state.
You're messing
Or-
up my education.
What?
You're messing up my education.
Well, it's only 2 days this month.
What are you gonna make us do?
I don't work on the food that day.
No.
Definitely is.
You give us like a 5 hours.
If I did that, then nobody would do anything.
Yeah, right.
I would.
I would.
I'm trying to get your
Hey, Mr. Lewis.
Morning.
Who's fired? Go ahead and try this one next. Oh, yeah, fine.
Do you want to change your grade rather than him, because she's done that, so I'll give her a teacher aide. You want to talk to him and see about changing your grade?
Is this the report card?
No, this is what she's got right now. But he says she's done. So you need to talk to him, I guess.
But this is on
So geometry. Yeah, geometry.
second use geometry. Yeah. Oh yeah, I did. We were in my room last year. Never mind. Okay.
Last semester.
Yeah. So she finished my class.
She evidently finished the class, yes. You want to talk to him and change your grade?
Sure.
That's going to be a better way to do it.
Probably easier.
Yeah. And this guy here, was in,
Oh,
the one with you.
he didn't just swap.
Wow. Did she just start all over again?
No.
Can you set up a log at third period?
At his rate, yeah.
Yeah.
I don't know, but he's choosing. Yeah, you know what? So I'm looking. Yeah.
So if you can take care of it.
I will.
Yeah. You know that you've got the form, right? If you send it.
Yeah, the ones. Yeah, I can do that. Thank you. This is the ending grade here.
I don't know. You gotta talk to Mr. Limbaugh.
Okay, I will. I'll make that note here.
He called me and I've got a place for her to put her third period. So.
Okay, thank you.
Is it answering me?
No, it's gonna be positive because negative divided by negative is positive.
That is a fact. A negative divided by negative is a.
Well, that's what you get. Like, that's what you come up with. But I don't know.
Or you.
You can't have a negative exponent.
Oh, you can't have a negative exponent.
Well, no, it's like that. Oh, shit.
You'll get used to it.
Bad influence.
I really like that shirt. All the colors are psychedelic, all melted together.
Oh, I keep forgetting you're talking about my shirt. You're like talking about. Have you ever seen a Big Bang Theory?
I've seen Rose.
Sheldon Cooper's shirt.
Oh, this.
There was a lot of like spring lantern.
Yeah.
Want to eat your stuff?
I like it.
He has the actual.
When he tries to make up his tricks in the bar.
Alrighty, let's get back to him. Huh? So, same situation as before. I want to get rid of those logs. What can I do here?
Based
Yeah, I can go base 10 on both of those, so I can make them exponents. So this becomes base 10 log of 3 minus 2x. That becomes 10 to the negative 1. So here, logs are opposite of each other, or inverse, I should say. And that's going to give me
0.1.
Yeah, so there's a couple things you can do. I went with 1/10 before, but 1/10 is simply 0.1. You guys cool with 0.1? Is that what you guys want? Okay, so 0.1. That at that point I'm going to move. I'm going to subtract 3 to both sides. That becomes negative 2x, negative 3.9, 2.9. Yeah?
Wait, where
What?
are you getting this point?
10 to the negative 1 is 1/10, because you have to take the reciprocal, remember? Can you have a negative exponent?
No.
No, so what you'll have to do is you'll have to reciprocal this. So right now it's 10 over 1, correct? And if you flip that, it becomes 1 over 10.
Okay.
Now 1 over 10 is just 0.1. That's what people wanted to go with. I would have left it as 1/10, but I'm not everybody. So at this point, I'm just going to divide both sides by a negative 2. That is 1. And x is equal to that quotient, which happens to be, how much?
No, positive one.
Positive. Oh.
Did you say 1.45?
Yeah.
Yeah, because negative over negative makes a,
I still did it right.
even on a bad day.
I still did it right.
That is all I've got, guys.